Okay, in this screencast we're going to learn how to solve polynomial inequalities and rational inequalities. So let's just jump right in. If I've got a quadratic inequality, then what I want to do is make sure that one side is 0, and I'm going to try and factor the other side or solve it any way I can. This will factor into x plus 4, x minus 1, less than 0. Now it's tempting to just say that x is less than -4 and x is less than 1, but that's not the way it works with polynomial inequalities. So what we're going to do is build a little sign chart. Okay? Now, no, I put in less than or equal to, and that should just be less than. Okay. So, I know that x equals 0 at -4. So I'm going to put an open circle at -4 because I do not want to equal 0. I want to be less than 0. I know that x equals 0 at +1. So I put an open circle at +1. I've divided my number line into 3 regions: less than -4, between -4 and 1, and greater than 1. So let's test a point in each region. So let's pick -5. Okay, if I put in -5 into this first factor right here, I'm going to get -5 plus 4, which is negative. And then -5 minus 1 is also negative. And a negative times a negative is positive. So any point to the left of -4 will give me a positive result. Now let's pick a point between -4 and 1. Well, how about 0? Okay, 0 plus 4 is positive. And 0 minus 1 is negative. Positive times a negative is negative. So any number between -4 and 1 will give me a negative result. And finally, let's pick a number greater than 1. Say 2. 2 plus 4 is positive. 2 minus 1 is also positive. Positive times a positive is positive. Now what I want is all results that give me answers that are less than 0. In other words, negative results. So here's our region that gives us that. All values of x between -4 and 1. So I can say that x equals -4 to 1. Okay, this example is a cubic, but it's the same idea. I'm going to try and factor and figure out where my critical points are, the points where x equals 0. So you see that in the first two terms I can factor out an x squared, leave me with x plus 3. And in the last two terms I can factor out a -4, which also leaves me with an x plus 3. And now I can factor from this term an x plus 3 and from that term an x plus 3. So I end up with x plus 3 times x squared minus 4 is greater than or equal to 0. Then I can factor further. And now we're ready to list our critical points on the number line. Okay, x equals 0 at -3, and it's okay to equal 0 because it's greater than or equal to. So at -3 I put in a closed circle. At -2 there's another place where x equals 0. And at +2 there's a place where x equals 0. So this is divided up into 4 regions. So let's pick a point to the left of -3, like -4. The first factor will be -4 plus 3, which is negative. The second factor will be -4 plus 2, which is also negative. And our third factor will be -4 minus 2, which is also negative. So I end up with 3 negatives multiplied together, which gives me a negative. Let's try a point between -3 and -2, like -2.5. Okay, the first factor will be -2.5 plus 3, which is positive. -2.5 plus 2 is negative. And -2.5 minus 2 is negative. A positive times a negative is positive. Okay, let's try a point between -2 and 2, say 0. 0 plus 3 is positive. 0 plus 2 is positive. 0 minus 2 is negative. Positive times negative is negative. And our last region, pick a number greater than 2, say 3. Okay, 3 plus 3 is positive. 3 plus 2 is positive. And 3 minus 2 is positive. Not 2, it's positive. 3 positives multiplied together give me a positive. Okay, so what regions do we want to shade? We want all the regions that make this polynomial greater than or equal to 0. So I'm going to pick the positive regions because those are where it's greater than or equal to 0. Now you may have noticed a pattern here that the signs alternate. Minus, plus, minus, plus. That's no accident. If the degree of each factor is 1, then they will alternate from region to region on your number line. So that's a nice thing to remember. Oh, let's write their answer in interval form. So that means that x is equal to brackets -3 to -2 and 2 to infinity. Now, it's no accident that these are the regions that are positive. If we graphed this function, look what we would get. And look where it's above the x-axis, from -3 to -2 and from 2 to infinity. So you can also solve these by graphing. So here's the procedure for solving a polynomial inequality. You get everything on one side of the equality, of the inequality, so the other side is 0. Then you determine the real zeros of the polynomial, hopefully by factoring. If it's a quadratic, you may have to use a quadratic formula. Then you set up a sign chart on the number line and you test the values. Rational inequalities are inequalities that involve fractions, and a critical value of a rational expression is one that makes either the numerator or the denominator equal to 0. We have to take both the numerator and the denominator into account. Now, solving rational inequalities is just like solving polynomials. You want to make sure one side is 0. You're going to find the real zeros of the numerator and the denominator, and then you're going to test those values on a number line. So let's do an example. First thing I want to do is get 2 over on the other side, so I'm going to subtract 2 from both sides. So now one side is 0. I'm going to get a common denominator, so I have one expression on the left. So I'm going to multiply the top and bottom of 2 by x plus 1. It's kind of like 2 over 1, right? Then I'm going to combine them into one big expression. And combine similar terms, so I get x plus 2 over x plus 1 is less than or equal to 0. So our critical numbers are -2, which makes, I don't want to put it over there, do I? Okay. -2, which makes the whole expression 0. And I can fill it in because less than or equal to 0, and -1. I don't want to fill that in because that would make the denominator 0, which is a big no-no. All right, so let's test our regions. Let's put in a number to the left of -2, like -3. Okay, so if I put in -3, the numerator becomes negative, and the denominator is also negative. A negative over a negative is positive. Let's pick a number between -2 and -1. Say -1.5. The numerator will be positive. The denominator will be negative. A positive over a negative is negative. And finally, put in a number to the right of -1. Say 0. And 2 over 1 is positive. Okay, so we want all the values that make the thing less than or equal to 0. So we're going to shade in from -2 to -1. So our answer is x equals, close brackets, -2 to -1 parentheses.